Hey, third grade, I am going to be going over some examples or more examples of questions that are how you're going to see your questions being asked when you're being tested over equivalent fractions, okay? And today you guys are going to be taking a quiz over equivalent fractions. And so if you do not have your fraction strips made, I really hope that you get those made before you take this quiz, because I want you to be using your fraction strips on that quiz, okay? So you need your whole, your halves, your thirds, your fourths, sixths, oops, and your eighths, all right? So if you do not have these before you take that quiz, I highly encourage you to get them done, because that's going to really help you answer these questions and get a good grade on your quiz, okay? So I'm going to be showing you some examples of questions of how, maybe something similar that what you're going to be asked, and how to use your fraction strips when you're solving these problems, all right? So here we go. Here's the first one. Kim drew 2 number lines on her paper. So here are the 2 number lines, all right? I am going to label my number lines, okay? How many sections or parts do I have on this first number line? Good. We have 4 sections or 4 parts, okay? So this is going to represent 1/4. If this is 1/4, what is this? Good job. 2/4. 1/4, 2/4, 3/4. Okay? And this is going to be 0 and 1. All right? Now let's look at this bottom number line. Sorry. How many parts or sections do we have in that bottom number, in this bottom number line? Good. We have 8. 8 sections. So each section represents what fraction? What unit fraction? Each section of this number line represents what unit fraction? Good job. Each section represents 1/8. So this is 1/8, but also that section right there would be 1/8 of the section. That would be 1/8 of the section, and so on. This would be 1/4 of this section. That would be 1/4 of this section. That would be 1/4 of this section, and so on. But when you put the sections together, that's how you get your fraction, okay? This is going to be 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. This over here would be 4/4, because when your numerator and your denominator are the same, you have a fraction equivalent to 1. You have a whole. You don't need to call it 4/4, but I'm just going to tell, like, that's what that is, okay? In case you ever see that, 4/4 or 8/8 in this case is equal to 1 whole, all right? Which statement below is not true according to the number of lines shown above? 2/4 is equivalent to 4/8. Here's 2/4. Directly below it is 4/8. If you're not sure, you're like, I don't know, can't tell on my number line, get out your fraction strips. So I'm going to fold it to represent 4/8. 1, 2, 3, 4. And I'm going to fold it to represent 2/4. Are those 2 equivalent? Yes, those are equivalent. Okay, I'm going to put a check mark by it because that is a true statement. 1/4 is equivalent to 2/8. Well, I'm going to get this piece out again. Are those 2 fractions equivalent? Yes, they are. 6/8 is equivalent to 3/4. 1, 2, 3, 4, 5, 6 is equivalent to 3/4. One, two, three. Are those equivalent? Yes, those are equivalent. Good job. You guys are becoming really, really good at equivalent fractions. 2/4 and 3/8. So I'm going to fold this till I can only see 3/8. There's 3/8 and 2/4. Are those equivalent? No, they're not. Good. Those are not equivalent. And I'm looking for the answer that is not true. I only have one answer with an X, okay? I know that it's really easy to see a check mark and you read the word true, you see a check mark and you just click it, or you circle your answer, or you click your answer. Not true. So I'm looking for false. I'm looking for the one that is wrong, all right? Let's do another one. Now, these are in circles. You have fraction circles in this problem. That is okay, all right? You can have fraction circles and still be using your fraction strips. There's nothing wrong with that. Remember, you can access your virtual manipulatives if you want to be using circles, and you can find your virtual manipulatives under your today topic, and they should just stay there, okay? Tara used an area model to represent equivalent fractions. Which fraction is equivalent to 4/6? So I want one of these models is going to be equivalent to 4/6. Well, let's figure out what this fraction is first, and let's label it, okay? What is this circle? What is that fraction? What fraction is being represented? Good. Four, 6 is being represented. What is being represented in this fraction? Two-thirds. Awesome. What fraction is being represented here? Awesome job. 5/7. Okay? Now, so this is the fraction that you're trying to find an equivalent fraction for. Is 2/3 or 5/7 going to be equivalent to 4/6? Okay, so I'm going to get my 4/6. So I'm going to get my 6ths, and I'm going to fold it to where I can only see 4 of them. All right? And then I'm going to get my 3rds, and I'm going to fold them to where I can only see how many of them? Good, to where I can only see 2 of my 3rds. All right? Are those equivalent fractions? They sure are. All right? We do not have fractions of 7ths, okay? So we don't have anything to compare. But I'm just going to double check and make sure that one of the other answer choices isn't also correct, okay? So the other answer choice is 1/2. Are those equivalent? No, they are not equivalent. 3/4. Are 3/4 equivalent to 4/6? No, they're not. And 7/8 is not going to be equivalent. Your answer here would be 2/3. Okay? Let's do one more question. All right, number 4. Penny painted 3/4 of her board. Here is 3/4 of her board being painted. Okay? Tommy painted 3/4 of his board. Which statement is true about the painted boards? Okay, well, what do we notice about these two boards? Good. They both have 4 sections, okay? Both of the boards have 4 sections. And how many sections of both boards are being painted? Awesome. Both boards have 3 sections painted. But what is super important when you're finding an equivalent fraction? What is super, super important about the wholes? And when I say whole, I mean the whole picture, the whole model. In this case, the whole board. What has to be true about your wholes when you're finding equivalent fractions? Good. Your wholes have to be the same size, okay? If you are having a birthday party with your friend or your sister or your cousin or your brother, all right? And this is your cousin's cake, all right? And your cousin gets their cake cut into 2 pieces. So this would represent 1/2 and this would represent 1/2. You have a cake. Your cake is this size. You get your cake also cut into 2 pieces. Your cake represents 1/2 and this cake and this side represents 1/2, okay? Your cousin gets half of their cake. They get this much. You also get this much of your cake. Even though you and your cousin have eaten half of your cake, did you guys eat the same amount? Good. No, you did not eat the same amount because your whole cake is not the same size. Your cake is about the same size as half of your cousin's cake, okay? So you did not eat the same size because your whole is not the same size. Now, if your cake was the same size, all right, this is your cake now, and you just cut it this way. This is 1/2, and this is also 1/2, all right? And you ate this one. Did you and your cousin eat the same amount? You sure did, even though your parts do not look the same. Okay, this is a long rectangle, and this looks like it's cut into 2 squares. Even though your cousin and you did not, or your parts do not look the same, your halves do not look the same, you ate the same amount of cake because you both ate 1/2 of your cake, and your cake is the same size whole, okay? So let's look at these answer choices. Penny and Tommy used the same amount of paint because they both painted 3/4 of their board. Is that going to be true? No, that's not going to be true. Why is it not true? Good. Their boards are not the same size, okay? The whole board is not the same size. So that is not a true statement. They did not use the same amount of paint. Penny and Tommy used the same amount of paint because both boards were the same size. Is that a true statement? Good. That is not a true statement. We just got done saying that the boards are not the same size. Tommy used less paint because his board was smaller. Is that true? Yes, Tommy's board is smaller. Okay? Penny used less paint because the area of her board was smaller. Well, is Penny's board bigger or smaller than Tommy's board? It's bigger, so her area is going to be bigger, not smaller. The correct answer here is letter C. All right, you need to be using your fraction strips when you are solving your questions on your quiz today. Let us know if you have any questions, and if you need help, please hop on office hours.